Okay, YouTube, this is my second video on my module on factoring, which we're going to focus on factoring trinomials, okay? This is actually a very, very good strategy that I'm about to share with you here that works with basically any trinomial that's factorable, but we say a trinomial of the form ax squared plus bx plus c. You'll sometimes hear this referred to as quadratic form. Little trial and error here is written, and sometimes that's necessary. But basically what we want to do is develop a strategy for factoring these. So we're going to assume for the moment that there's no greatest common factor between any of these three terms here. But step number one is going to basically be this. When we talk about our FOIL process, we're going to take this trinomial and we're going to write it as the product of two binomials. And the first thing we're going to do here is we're going to find two first terms whose product is ax squared. That is, we know that when we multiply out this these two binomials that we're factoring into, this times this is what are responsible or giving us our ax squared term. So what we're going to do is, first of all, find two numbers that when we put them up front allow us to get this ax squared term. That's all we care about. The second step is essentially going to be this, and now we're done with that first part, the f. What we're going to do next is we're going to find two terms that go in the last two term spots, that when we multiply those, we get our last term here in this product. In other words, we're going to find two last terms that when we multiply them out, they give us our constant term. And that's really kind of an easy thing to do as well. So you'll notice that we've covered our bases with the first term and the last term. The only thing that we have left over are the outer and the inner terms. And basically, those outer and inner terms, when you multiply those out and add them up, they should kind of give us this bx term in the middle, okay? So we say on step 3 here, by trial and error, perform steps 1 and 2 until the sum of the outer and inner product is bx, okay? So in other words, at this point, we would have gotten this because we know that produces our ax squared, check. We would have put in two terms here for the last two. That would have produced our c term, our constant term, check. And then the last thing we do is we just multiply these and add them up and say, well, look, when I do that, do I get the middle term? Because if we don't, we're just going to move things around until we do, okay? That's where the guess and check part comes in. So let's take a look at these. I've got 6 examples here that I want to kind of work through, but looking at this first trinomial, or at least these first 4, one thing I do want to point out about them is all of these have leading coefficients of 1, and that's going to be kind of a nice thing here when we get through the first 2. But looking at this first example, we say, well, look, if this is factorable, using our guess and check technique, FOIL, let's start with the f part, saying, well, what can I multiply here and here that would cause me to get 1x squared? And about the only thing I could think of is x and x. So we'd say, check, I've got my x squared if I multiply these out. Now let's take a look at the L. So what can I put here and here that is going to cause me to get a positive 8? Now, when I think of positive 8, we could list out some factors here. We say 2 and 4, -2, -4. We get 1 and 8, -1 and -8. The idea, though, is going to be this. When I put these in here, I'm going to go with, say, +2 and +4. I know that I've gotten my 8 term. Like, that's guaranteed no matter which of these combinations I insert into these two quantities here. So where the guess and check part comes in is where we say, well, let's check our outer and inner here and multiply those out. Next times 4, I'm going to get 4x, and 2 times x, I get 2x. And when I add these up, I get 6x. And the question is, do I get the middle term? And yes, we got the 6x, okay? So the idea that I want to get at here, at least with the trinomials where a is 1, is we could have done this actually a little bit quicker, more quickly. And the reason why I say this is because x plus 2 times x plus 4, really, I know I'm going to have an x and an x in the front just because this is 1x squared. And I know I need two factors of 8 here. But when you look at these factors of 8, let's say I were to add all these up, add them up. Let's add them. I would have gotten 6 here, I would have gotten -6 here. I would have gotten 9 here, I would have gotten -9 here. I could really easily have told you that 6 is what I needed to get in the middle. So we're not just looking for two factors of 8, but we're looking for two factors of 8 that also sum up to be the middle term. Now this only works if your leading coefficient is 1. So let's give this a shot on a few more of these here. As a matter of fact, I say, okay, I want to factor these two. I know I need to get this first, so I'd say x and x are going to give me that x squared. And in terms of 40, what are some factors of 40? I could say like 4 and 10, -4 and -10. I'm not going to list that for now. I say 2 and 20. I can say 1 and 40. If I think of anything else, I can say 8 and 5. And I think I've exhausted all possibilities. They could also both be negative and still give me a positive 40 when I multiply them. But the question is, which of these also adds up to be 13? I say, well, easily I'm spotting it's got to be my 8 and my 5. So I say 5 and 8. And again, we could check this. We could say check your outer and your inner. You get 8x plus 5x is your 13x. So now, moving on to these last two. This is interesting. These last two examples actually have products that came out to be negative on our constant terms. So what we're going to end up with here are two binomials multiplied together. Again, since we're starting with the f part, we say, I got to get this part first. It's going to be x and x in this case. And we say, well, what are some products or some factors of negative 18? So I got negative 1, positive 18, positive 1, negative 18. We don't have to list them out every time. We can say 3 and negative 6, negative 3 and 6. Which of these also sums up to be a positive 3? And when I sum a positive 6 with a negative 3, I get my positive 3. So we're going to say negative 3 and positive 6. And again, with the guess and check method, I say, well, I got my x squared. I've got my negative 18 when I multiply those. Check your outer and your inner. Yes, I get 6x and negative 3x is a positive 3x. And then last but not least, on this last one here, we say, well, x and x, going to give us this first one. What are some factors of negative 14? Well, here's one thing I do know, and I do want to say this time. These signs can't be the same if they multiply out to be a negative. Also this, I'd say, well, they add up to be a negative, so whatever these two factors are here, the negative one's going to be the bigger one because it added up to with the smaller positive one to be a negative middle term. We say, well, what are two factors of 14 that are, say, 5 apart from one another? And I could think, you know, if I had a negative 7 and a positive 2, this would certainly work. So checking my outer and my inner here, I get negative 7x, positive 2x. You know, I get my negative 5x in the middle. So again, we could FOIL that back out and distribute, basically, and see that we get what we started with. But these are the factored forms. Now, the question exists, what if I don't have a leading coefficient that is 1? This is where that guess and check method really just is kind of an important thing. So let's try that out here, where we say, well, let's start with this 8x squared. What could I put in the front here? So I noticed that I could put like x and 8x, and in the back here we say, well, what's going to give me a negative 3? Now, that's a prime number, so there really aren't many options here. I could say maybe a positive 3 and a negative 1. You'll notice that I've taken care of this part first, and I say, well, I've taken care of this part next. You know, I got a negative 3. The question is, do we get the negative 10x in the middle? So this is where we check our outer and our inner, and I notice if I took this times this, I get negative x, and 3 times 8x is positive 24x. Adding these up, I get 23x's. And that is not what I need in the middle. I need a negative 10x. So before I, try this again here, this is a guess and check method, remember, one thing I'm going to point out is this. If you're going to choose factors, say, in the front here, of 8, it is always, I would say, wisest to choose the closest two factors of 8 to one another. That is, 1 and 8 were pretty far apart, whereas 2 and 4 are pretty close together, okay? So we say 2x and 4x. And in terms of what I could put in here now, I could say maybe negative 3 and positive 1. So I know this. I know I've got my 8x squared. Boom. I know I've got my negative 3 in the back. So let's check our outer and our inner. And in this case, I get 2x times 1 is 2x. Negative 3 times a positive 4x is negative 12x, and so I get negative 10x. So, booyah, we got what we needed. So let's try this again. Looking at this one, I say, give me two factors of 6x squared that we could put in the front. Now again, I could put 6x and 1x, but remember what I said. I'd say 2x and 3x are a little bit closer together. So we'll choose those. We're good. Okay, we got our first term. Factors of negative 7. Well, there aren't many. It's got to be a 7 and a 1. And because this is negative, I know these have to have different signs. So one thing I will point out is this is positive in the middle. So if I wanted this to come out to be, say, positive in the middle, I want to take my bigger number here, which is the 7, and make it positive. And I want to take it times, say, the 3 here. You just play around with this too. But I noticed that if I were to do it this way, I'd say I get a negative 2x here and a positive 21x here in the middle. And summing those together, I get my 19x positive. So if that's the case, then we'd say then these are my factored terms here. So before we tune out of this video, I want to look at some trinomials having two variable types. I just want to point out the fact that the guess and check still works here. People freak out about this, but I notice that I have two trinomials here and there are no greatest common factors. That's what I would check for, of course, first. But since there are none, and I see that this is somewhat in quadratic form, I could say, well, I think that 2x and x would be good appropriate things to give me my first term here. What would give me my last term here? I notice I have a positive 3y squared, so it could either be a plus 3y and a plus 1y, or it could be a minus 3y and a minus 1y. Here's all I want to do. I want to check the outer and the inner terms. And what I get here is 2xy, it's a positive 2xy, and a negative, it's a positive 3xy. And those add up to be a positive 5xy. So notice what you have in the middle is a middle term. We have a negative 7xy. So maybe what I need to do to get a 7 here is actually switch my 3y and my y around. And you know what, also this, maybe I need to make them both negative. So let's try it this way this time. Remember, it's a guess and check method. I have 2x and x. This time though, let's put our y here and our 3y here. And also let's make them both negative and check the outer and the inner again. In this case I get 2x times negative 3y is negative 6y, 6xy. And then we have here a negative y times a negative x is negative xy, and adding those together I get negative 7xy, which does confirm that we get the middle term here. So this is our factored expression. And again, let's try this guy. We have definitely 3x and x. And then back here we'd say, well, 4. Now again, just like I wouldn't choose 1 and 4 right off the bat because they're far away from each other, I would probably start by saying, how about 2y and 2y? And I notice also this. This is a positive 4y squared, so these have to be the same sign, either both positive or both negative. And since they have to add up to be negative, I'm going to make these both negative. I'm going to say, well, let's try 2y and 2y. And if it doesn't work, we'll try 1 and 4. So 3x times a negative 2y is negative 6xy. And negative 2 times xy, or y, sorry, negative 2y times x is negative 2xy. And adding these up, I get negative 8xy. So my suggestion, as a matter of fact, fails. And that suggestion was choose two factors that are close together. So maybe instead of 2 and 2 here, we need to try 4 and 1 for this. So again, we'll give this a shot. We'd say, well, I know I need to have a 3x and x to get my 3x squared. And I know that these both need to be negative. And we're going to try, say, how about y and 4y. That would give me a 4y squared in the back. So checking the outer and the inner here, I get, well, negative 12xy with these two, and negative xy here. And I notice that I get negative 13xy, which, it's kind of great because that's what we needed.